recording. So there is homework as a reminder that's due Tuesday. And again, the quiz is posted. Excuse me, the first quiz is posted and it's due Wednesday, okay, before midnight. I think 11:55 if I remember correctly. You can ask me questions about it as well. You know, you're more than welcome to. You know, if you have a question, don't be afraid to message me or email me, I mean. But actually, make sure you send me an email. 1 second, please. Make sure you message me through Lumen so that I can see the problem you're working on. And you don't have to show your work either. You just have, you don't have to send me your work. You only have to do that on the exams. So, someone had a question?
Yeah, I just joined the meeting. What's due on Wednesday?
Oh, the first quiz.
Oh, okay.
Okay, it's on Lumen, so. Okay. All right. So yeah, again, good question. So it is on. So again, the quiz and homework are on Lumen. So the only thing you have to show your work really is for the exams, and again, those are take home as well. Excuse me. All right. Any other questions? All right. All right. Let me just stop my camera. So there we go. All right. Okay. So we're still in the process of factoring. I tried emailing this to people, and for some reason the Blackboard said the email couldn't go to everyone, so I posted it on Blackboard under week 3 in case you don't have an outline of the notes. I will post a full set of notes later, so, and the YouTube videos as well. Okay. All right. This is actually something I forgot to say last time. But when we're factoring polynomials here, we're only focusing on polynomials that have integer coefficients. Yeah, I don't know so much for factoring, although I guess you could do this, but theoretically you can you could look at polynomials whose coefficients are real numbers, whose coefficients are rational numbers, even complex numbers. But we're going to focus only on the integers. Okay. Good. All right, that's good to know. So we're only focusing on the integers. Okay. And if you remember, this is what we were working on last time, factoring trinomials of this form, right? Where notice we have degree 2, trinomial meaning there's 3 wonderful terms here. Okay. The leading coefficient is 1. Okay. This integer is capital B, and C is also an integer. Okay. And to factor this, right? Remember, there is a process I mentioned. I did fix up the notes a bit. You're looking for 2 integers, little b and little d, so that these 2 hold. So capital B is the sum of b and d, and capital C is the product. So capital B, you want 2 integers, b and d, so that capital B, the coefficient of x, is the sum, and capital C here is the product. In other words, you want to fill in the blanks, so to say. And once you get those blanks filled in, once you find your b and d, you can factor easily. Basically, this is what you have to do. You have x plus the first number times x plus the second. And also, this is something I should point out. If for whatever reason you're not able to find a b and d, then the polynomial, you cannot factor it if there is no such b and d. Okay? So again, if you cannot find a b and d, then this polynomial is actually said to be irreducible, which basically means it cannot be factored. Notice also the GCF of this is actually 1. Well, depending on what C and B is, actually, I should say. So anyway, so we have that. Let's do some examples. I think we did this one last time. Let me go through it again, though, just to be on the safe side. So here we have 7 and 10. So we want two numbers, right, whose product is 10 and whose sum is 7. Product is 10, sum is 7. Well, what numbers are going to do that? Let's try 10 and 1. So 10 is 10 times 1, right? But is 7 equal to 10 plus 1? No, that's not true. So unfortunately, 7 and 10 are not the numbers that are, 10 and 1 are not the numbers we're going to use. 10 and 1 do not work. Do we give up? No, let's try something else. What about 5 and 2? Well, 5 times 2 is 10. 5 plus 2 is 7, so that does work. So 5 and 2 do work, and so because of that, what we end up getting is this. So 5 and 2 are our little b and little d, so we have this factorization. And here I just did a check. You know, it is good to check your results, you know, to see that this equation is true, and it does work out. Notice here, though, the x squared plus 7x plus 10, the GCF of that is 1. Now, how do I know that? We have a non-zero constant term, right? So remember, the GCF was b times x to the m. That m would be 0 because we have a non-zero constant term. But that b, which again is the greatest common factor among the coefficients and the constant term, well, b would be 1 since a coefficient is 1. Okay. Good. All right. Are there any questions on this one? Okay, let's do another one then. So here's another one. Let's factor x squared minus 9x plus 20. Now notice here, we want two numbers whose product is 20. The sum is negative 9. Remember, you must include this minus sign. Okay? You have to include that. Okay, so again, we want two numbers whose product is 20 and whose sum is negative 9. Well, do 10 and 2 work? Actually, should have been, oh, sorry, this should be 20. That's what that is. Okay, so do 10 and 2 work? Well, 10 times 2 we know is 20. That is true. But is 10 plus 2 equal to negative 9? Well, no, it's not. Remember, we want the two numbers that satisfy both of these equal signs. So 10 and 2 satisfy the first equation, the first equal sign, but it does not satisfy the second. So 10 and 2 are not going to work. What about 5 and 4? Well, 5 times 4 is 20. That's cool. That's good. 5 plus 4 is not negative 9, though. It's 9. But you can see we're kind of close, though, right? I mean, we know 5 and 4 do appear. I mean, they do satisfy the first equation. The second one they're close to, but they're not equal to negative 9. They're equal to 9. Okay, but what can we do? Well, what if we just negate them? Right? The first equation still holds by our sap and sun rules. I think that's what they call it. Excuse me. If the signs are alike, right, we get a positive answer when you're multiplying. So -5 times -4 is still 20. And the sum is now -9. So that tells us then the numbers we're going to use are these two, -5 and -4. And so we have this. If you did write it as plus -5 and plus -4, that's fine. Same thing. And again, it's good to check. That's what I do. Okay. Just hold on a second.